Hello and welcome back. Welcome to a chapter on how computers to find each other on a network. So we're going to be discussing how computers actually communicate with each other. You are going to have a better understanding on how a host will reach another host in a LAN and also in um, and outside of LAN using an IP address and a MAC address. So we're going to be discussing IP addresses and MAC addresses, IPv6, IPv4, um, and how computers actually communicate with each other using these addresses. So you should be able to differentiate why do we between the should be able to differentiate between a MAC address and an IP address. All right, by the end of this chapter, and hopefully you'll have a better understanding the difference between an IP and IPv4 and IPv6, version 4 and version 6. But before we begin, I want to just point out a couple of things for you. This chapter is going to be a little bit long. It might take us over an hour to complete. So please, what I want you to do every 20 minutes or so, hit the pause button, go take a break, get a cup of coffee, use the restrooms, walk around. I don't want you to sit through the whole lecture, and because most likely you're going to lose something between now and then. So just take a break every once in a while, even if you have to come back in an hour or so, or even after a day to finish it up, that's fine. I want you to, as long as you can concentrate for 20 minutes, that's what counts. So do it 20 minutes at a time, it would be perfect. All right. And I want you to write down everything that I told you. So before we even get into everything that I tell you to, of course, just like the last chapter, I want you to write down and you'll submit that as your homework. Even before we begin to through the slides, I want to go over for even though some of you um, might have experience in this, but I want to go over converting binary to decimal, decimal to binary, because we're going to be talking about IPv4 addressing when it's in a decimal format and converting it back to binary and binary to decimal. We're also going to be talking about IPv6 and the MAC address, and both of these addresses are in hexadecimal format. So I want you to understand how to convert back and forth and understand what they are. Now, by the way, I want you to submit all of this. So I want you, everything that's typed in this Word document, I want you to repeat it and repeat everything that I type also in here, and anything that if I ever go back in here and I type anything, um, please type that as well. And by the way, you can also, the notes that I asked you to add from the slides, you can add them on the bottom, the down. Okay, so all you have to do is just submit one document. So let's start with this right here. All right. Digital devices, computers, routers, switches, all host, everybody communicates in binary, zeros and ones, high and low voltages. So whatever we type in terms of an address, either a MAC address, an IPv6 or an IPv4 address, it's always converted into ones and zeros. That's how the computer understands it. Okay, so we start out with converting decimal to binary, binary decimal. Typically, um, the IPv4 address, excuse me, is written in decimal format. So when you type in, for example, an address such as 192.168.10.3, that number is converted um, into binary. So for example, so if I asked you to, if you have an address such as let's see, 192.168.10.3, and this is the oops, I'm sorry, 192.168.10.3, and I want you to, what does the computer see? So here's what the computer when you type this in as an address. First of all, you take the 192. By the way, what I want you to do is that you see these numbers on the top right here. I want you to remember them. Actually, this is not 127. Change that to 128. It's not 127. By the way, we'll go over this again in the class, but I want to give you a preliminary, the for those people that are not familiar with this, you'll get to see it twice. How do we get these numbers on the top? I'll go over all of that with you on in class. So let's say what you need to do is, for example, you take the 192, the computer takes the 192, and how do you convert that into binary? You say, okay, is there a 192 in in 128? You say yes. There's 1. Okay. 192. You can subtract 128 from 192. You end up with 64. So there's a 164 left. And that's it. So 128 plus 64 is 192. And then the rest are zeros, right? What's 168? So how do you convert 168? 168 is 128 plus 32, right? So you put a 1 under the 128 and under the 132, and then the rest are zeros, right? What's 10? A decimal 10 in binary. 10 is, there is no 128 in 10. There is no 64. There is no 32. Too much. 16 is too much. 10 is an 8 plus 2, right? So you put a 1 under the 8 and under the 2. Okay? How do you connect? How do you connect? What's a 3 in decimal? So a 3 would be what? A 3 would be, there's no 128, no 64, no 32, no 16, no 8, no 4. It's 2 plus 1, so 1 and 1, right? So these are 32 bits. This is what the computer sees. 110000 blah, 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 all the way to the end. So the IPv4 address is always 32 bits. Each one of those is 32 bits, okay? Each byte. This is called a byte or an octet because it's 8 bits. We'd like to write it in decimal and separate them by a dot. But when you type this in as an address, the computer converts it into ones and zeros like this. All right? So let's just take another number. Let's say I want you to convert 234 into binary. So what do we do? So you go here and you say, okay, is there 128 in 34? The answer is yes. So what you could do if you want, you can say, all right, 234 minus 128. I'm left with 106. So is there 106 in 64? Yes. So you put a 1. So you take then you take 106, take away whatever you put the 1 under 64. How much is left? 42. Is there a 32 in 42? The answer is yes. So you put in another 1. All right, take away the 32 from 42 minus 32. You're left with 10. Is there a 16? No. So you put a 0. Is there an 8? What's a 10? It's really 8 plus 2. I'm sorry, 2, right? And this is the binary equivalent of 234. Okay? That's it. What's a 0 in binary? What's a 0? All zeros, right? So if I put a 0 in one of these bytes, it's all 8 bits. All bits are zeros. What happened when all the bits are 255? That's all ones. So all ones, if you add all of these numbers on the top, you get 255. So here's something to remember. You will never ever see an IP address, an IPv4 address that has in any of these octets something larger than 255. Okay, if it's there, if it's anything is larger than 255, you will know it's wrong. Okay, so please write this down because now we're going to go the other way. What if somebody gives you binary and you want to go to decimal, right? So here, I'm just, oh, you know what? You can leave it. I'll just move this down a little bit. Here we go. Let's say I want to convert the number 0011 0011. What's that in decimal? So all you have to do is put in the 0 here, 0011 0011. All you have to do is wherever you see a 1, add the numbers on the top. So I have 32 plus 16 is 48. 48 plus 2 is 50. 50 plus 1 is 51. So this is equal to 51. right? Let's say I give you an address 1001 0110, right? So what do? You put 1001. How much is that? Well, let's see. You got 128 plus 16 is 144, right? Let me just make sure. 128 plus 16 is 144. Plus 4 plus 2 plus 4 plus 2, that's a 6. So this is equal to 144 plus 6 is 150, right? See how quickly you can do this? That's it. So now you should be able to convert binary to decimal, decimal to binary, right? The number's right here. You just add the top on, you add the number on the top. If you see a 0, don't bother, just skip it. All right, just remember when you type an IP address, you convert that, the computers and the devices convert that into binary. Now, the let's start converting binary to hex to binary. Your MAC address, the physical address that comes in on the what do you call it? On your MAC address is a 48-bit number and it's written in hexadecimal number. So these numbers are in hex. There are 16 unique digits. See the decimal, there are 10 unique digits from 0 to 9. That's 10. Binary, it's only 2 digits, 0 and 1. The hex, there are 16 of them. 0, and you start after 9, you use the letters A, B, C, D, and E. It's very easy to do. So if you have the binary, for example, let's say I want to convert 0, I'm sorry, 0, 1, 1, and 1100. So what you do is to convert that into hex, just separate them into 4 bits on each side. It's called a nibble, by the way. So 011, 011 is a 3, right? And 1100, you go down the line, 1100 is a C. So it's 1C. It doesn't have to be capital. So this binary 0111100 is 1C in hex. What happens if you have 1011, oops, sorry, 1011, and you have 000 or maybe 101? What is that? Just separate them. That looks like a B and a 5, right? So that's equal to B5. So what happened when 101 and 1000? How do you convert that into hex? It's 9, 8. Okay, just make sure when you write 9, 8, you have to identify it, that this is a hexadecimal number, not a decimal, right? So for example, this is, I'm going to write that in parentheses, that this is a hex. What is 98 in decimal? 98 in decimal. What is that equal to? Well, 98 is 0, 1, that's 64, plus 32, that's 96. And you got also a 2. See this binary number in hex? 98 in hex is different than 98 in decimal. So if you tell the computer that this is 98 in hex, it's going to convert it in this. If you tell it it's 98 in decimal, it's going to convert it into this binary. All right. So when you write 98 as an IPv6 address, the computer sees it as this because IPv6 is always in hex. If you write 98 as an IPv4 address, because IPv4 is also always written in decimal, the computer sees it as this. Completely two different addresses, two different numbers, in other words. Right? You can go, vice versa, by the way, also. How do you convert 3 and the letter F, right? 3F. Well, 3, you look at the chart, it's 0011. F is 1111, four ones. That's 3F. How do you convert, if anybody asks you, what is 3F in decimal? Going from hex to decimal, all you have to do is just convert everything to binary. Always convert to binary, then go to decimal. So you have 32 plus 16 plus 8 plus 4 plus 2 plus 1. And that will give you 63, right? What if somebody says to you, I want the number, I don't know, 160 in decimal, right? 160 in decimal. Give it to me in hex. So what do? Always go to binary. 160 is 1010 0 0 0 0 0, 4 zeros. That's 160. Well, now you break them up to make them in hex. Break them up into four pieces. I see 1010, and that is an A, and four zeros is a 0. This is, see how quickly you could do this? This is in hex, right? And this guy is, don't forget, is in decimal. All right. So hopefully this will give you an introduction about decimal and hex and binary numbers. The whole idea of writing the numbers in hex is to make the address concise, make it smaller when we are writing this. Okay, we'll go back to this and we'll go into the addresses as we move along later on with the lecture. So let's go back now to the chapter slides. So getting back into the slides, there are four different methods of using addresses. You can use the FQDNs, excuse me, the fully qualified domain names like www.xyz.com, or the name of the computer, or the host names, whatever. You can use port numbers to identify, like port number 25 is the SMTP, port 80 identifies the application layer, HTTP, FTP is the application layer protocol for FTP. HTTP is port 80. Port 25, I said, is the email. Or you can use the IPv4, IPv6 address. By the way, you need a combination of all of those. It's not just one to identify exactly the application. So IPv4 and IPv6 addresses is at the network layer, and at the data link layer, we're talking about the MAC address, the physical address. Okay, so let's start with the MAC addresses. What is the media access control address? Please write this down. The media access control address consists of, it's a 48-bit number, okay, consists of two parts. The first part is the organizational unit identifier. Okay, so what you do is you call the IEEE if you want to make up a MAC address, and the IEEE will give you a 24-bit number called the OUI. You take that, and the last 24 bits is the vendor serial number, who the maker of that NIC is. You sandwich them together, you'll get your MAC address. You take that MAC address and you burn it on a chip, and you stick that chip onto the on the NIC. So every NIC will have a 40-bit address, and that is your MAC address. That's your physical address. That's the address that the NIC will take to stamp on the frame before the data is sent onto the media. Okay, and there's a typical MAC address and a typical. And by the way, the NIC could be wireless or wired. It doesn't matter. There'll still be a 48-bit number there. All right, host names. The host names is, for example, what is the reason that you need? Here's a couple of things I want you to write down. Okay, an IP address identifies the location or the zip code, put that in quote, of the host that you're trying to reach, or the host or who you are, in what area, in what land, in what zip code you are in. All right. So it's like a zip code, really, an area of who you are and what network. That's what the IP address is for. When you turn your computer on, you are going to get an IP address from the DHCP server. So write that down. The DHCP server provides the source IP address of the host. So if you come in with your laptop to school and you turn your computer on, the DHCP server on campus, your computer immediately looks for a DHCP server, and the DHCP server on campus will immediately give you an IP address. You use that as your source. Now you need the destination IP address. So if you type www.xyz.com, the reason that you're typing the name is because you do not know the name, the IP address, the zip code of where the destination of xyz.com server is. So when you type in that name is sent to a DNS server, domain naming services server. They look up the name WXYZ and they give you the IP address. Here's another thing I want you to write. The DNS server provides you the destination IP address of the host that you're trying to reach, right? So you got to type in the FQDN, the fully qualified domain name, right? The last part of the fully qualified domain name, they end up with .edu, .gov, .mil, .com, right? All of those are called top level domain names. There's a whole bunch of domain names. So if you type www.yahoo.com, yahoo.com, microsoft.com, Amazon, eBay, all of these commercialized e-commerce companies, IBM, all of them are under the .com DNS servers. The .edus, all the universities from Rutgers to NJIT to Purdue to Stanford universities, all of these are under the edu. .gov is for the government. .net is for network companies. .org for nonprofit organizations. Just for those are the top levels. So when you type in a name, your computer immediately, depending on the last part of the FQDN, you'll go to that DNS server and look up the name for you and give you an IP address. I'll go into more details how this works in the classroom, by the way, and how a DNS server works with an HTTP and how does it provide. We'll do a little exercise in class and you'll see actually how that happens. Okay, so here's a whole bunch of different top domain names. So remember, the DNS server is the one that gives you the destination IP address, because we don't want to remember IP addresses. It's much easier to remember names. So that's where the DNS comes into play. And it'll just look up the name and gives you an IP address. And so, by the way, so you don't have to keep going back and forth and keep looking for the name. What your computer is going to do is going to cache in all of these names, caches them into memory. So next time you type in www.xyz.com, it's going to look up the cache, the memory that you have, because you probably went there already. And if you did, it already knows what the IP address, it gets it for you, and you don't have to go outside to the DNS servers and to get it. So you're already there. You already cached them in. All right. So that's that. You're going to go to the DNS servers. And here's you can have a cache server, by the way, on campus that caches in all the names of everything that you went to, so you never have to go outside your LAN next time to get to the DNS server, because it's going to take time to load up the web page that you're trying to get to. There are two ways of the DNS request. There's recursive. A query is that demands the resolution or the answer, otherwise it cannot be found. Or there's iterative, which means if you're a query where the local server issues a query to all other servers. All right, if this doesn't work, please give me, is there any other servers that can find a solution, find a name for me? And this is typically what happens. All right, so please write those two down, the two DNS requests, recursive or iterative. All right, so when you are, for example, there are two ways of the DNS can follow distributed database model. All right, so there is the primary DNS server that you have. And when you type in, for example, as we will see in the class, you can type in the name and an IP address. That will be inside a zone. Um, we can set that up, and we'll do that in class. I'll show you how to do that in class as a class activity, by the way. You can type in all the names and all the IP addresses. We'll create a DNS server, and we'll see it in action. Okay, so where all the names and the IP addresses, this is called a zone inside the DNS server. The primary DNS server holds the authoritative DNS database for the organization. That's where everybody goes to first. Zone transfer, all the name, you can have a whole bunch of DNS servers that communicate with each other, because if you send in a name that you want an IP address for and it's not in that zone, you'll be sent to a different zone. So what you want to do, if the primary zone that you have has changed, you can update that and send it to other DNS servers. That's called zone transfer. You know, copy your zone to someone else's zone. Okay, the Bind is the most popular DNS server software. It's an open source, and the code is publicly available to everyone. Microsoft has you can create a DNS server within Microsoft. We can easily do that. It's very simple to do that. And Cisco allows us to do that on their routers. Microsoft 2012 servers allows us to do that as well. Okay, and we'll set that up perfectly, as we will see later on. And the Active Directory, if and when we take a class in Windows Server 2016 or 2012, you'll be able to set up the in the Active Directory the DNS server. All right, so for example, if you type in the A address, that's a record for an IPv4 address. Quad A's, meaning you're looking for an IPv6 address. If it's C name, it's an alternative name to a host. It's like an alias. PTR is a pointer. It points to someone else's name. MX is for mail exchanger. So it depends on what. Most likely, it's either you're doing an A and AAA. So we'll do in class when we're doing the exercise, we'll do the A address just to look up for an IPv4 address. DDNS is the dynamic DNS is protocol that used along with monitoring software to monitor the IP addresses dynamically assigned to your home network by your ISP. It manages the dynamic updates of the DNS records for the domain names for home websites. So you don't have to really too much to worry about this. This happens in the background with your wireless router and your modem at home. So this is pretty much done automatically for you. You don't have to really do any configuration with that. All right, so here's one thing I want you to write down. Port numbers. Number one about port numbers. Port numbers identifies what type of application being encapsulated. Is it an email? If it's port number 25? Is it 69? And if it's post office protocol version 3? Is it port 80? Is it port 8, 443? So port numbers identify what type of applications. Port numbers are placed on the segment at layer 4, right? The second thing I want you to know, port numbers and an IP address together, such as this, is an IP address and port number 23 together, they are called a socket. So you want to reach this IP address and this application at this IP address, at this, whoever has this IP address. Okay, so, and also I want you to write down, there are 3 different types of port numbers. Please write those down because we will be discussing those in other classes later on. 0 to 1023 there are well-known port addresses such as 80, 25, 23, 22, and so on. Registered ports are ports that our company or an organization pays for and no one else can use. For example, port 2000 Cisco purchased port 2000 to use for iPhone for their iPhones, IPv phone, voice over IP phones. Dynamic or private phone ports. This is the range for them. This is where you actually use them every time you want to communicate. You use them as the source port to when you're communicating with your destination for a destination host. All right, there are two types of IP addresses. There is the old IPv4, which is 32 bits, and it's written in hexadecimal number. IPv6 has 128 bits and written in um, and it's written in hexadecimal. The first one, the IPv4 is written in decimal. All right, so the IPv4 is a 32-bit number, and it's broken down into four octets, right? 4 bytes, and no byte can be larger than 255, like we said. And there are 5 classes A, B, C, D, and E. So we will talk about this also in class. So class A is where you have for there class A means the first byte is the network address. Class B, the first 2 bytes or the first 2 octets are the network address. Class C is the first 3 bytes are the network address. Class D are for multicasting when you want to send data to multiple hosts in a network. And class E is really used for um, internet experimentation, for research. So really we need to worry about classes A, B, and C. This is the ones that you can use to communicate. You do not use class D and E. All right. So any address that goes from 1 to 126, that's going to be class A. From 128 to 191, that's class B. 192 all the way to 223, that's going to be your class C, right? So let me go to here, back to here, and let me show you what I'm talking about. So here I want you to write the following. Excuse me for a second. So I'm going to say class and first byte, and then we're going to say network slash host designation. So for example, if you are in class A, the first byte has to be between 1 and 127, even though it says 126. 127 is used for a loopback. The first byte is going to be a host, and the first byte is going to be your network address, and the last are going to be your host. If your IP address, if you're in class B, then the first byte has to be between 128 to 191. And if that's the case, then the first 2 octets are your network, and the last 2 are your hosts. If you're in class C, the first byte has to be between 192 all the way to 223. If that's the case, then the first 3 bytes or 3 octets is your network, and the last one is the host. For example, so if, oh God, let me hold on a second. So, for example, that's what I wanted to write. If you have the address 192.168.10.3, okay, what class is this in? Well, because the first number is 192, it's a class C, right? What's the network portion of the IP? Well, the network portion, it says the first 3 numbers are your network address. So it is 192.168.10. And typically you write, don't write the 3 because that's the host, 0 for the host portion. What's the host portion? That would be 3, right? The last part, right? 3. Let's do another example. Example 2. What happens if you have 10.250.123.80? All right, what class is this in? Well, you see the number 10, and between 1 and 127, though it has to be class A, right? What's the network portion? That is going to be the first byte only, right? And the first byte is a 10 here. So it is 10.000. Always write 0 for host when you're writing a network portion. What is the host portion? So that is going to be the last 3 digits, right? 250.123.80. All right? So that's how that's how routers know which network the IP address is in. So when a packet comes into a router, the router needs to look at the destination IP address, the zip code of where the packet is going to. So when it looks at the destination IP address that is stamped on the packet, first it needs to know what class this IP address is in so it can figure out the network portion of the IP and look up a chart called the routing table, try to find out if this network address is in the routing table and see where it needs to send it to. Just like when you send a package to the post office looks at the zip code, then he looks up a chart to find out where the zip code is located in the country and sees if he wants to send it east, west, north, or whatever, or south, right? The good thing that, to the post office, it's a little bit easier. He doesn't have to, those zip codes are not in classes. The zip code is a zip code. It's a network address, but the IP address has 2 portions, a network portion and a host. So we need to, the router is not concerned with the host. It needs to only look at the network portion. So that's why we need to break them down into classes. Later on, what we're going to do, we're going to just eliminate this classes and just use a mask like a subnet mask address where we mask the host portion of the IP revealing the network. That's what the subnet mask address is used for. But we'll discuss that on a different day. All right, going back, let's continue. And the 127.0.0, by the way, is the loopback address. So if you type ping, P-I-N-G, 127.0.0.1, your computer should respond. It should reply. This is telling you that your NIC is able to encapsulate a packet, put it into a frame, get it ready to be placed on the media, on the wire, and also what is it going to do is also it doesn't send it out, it's going to loop it back, bring it back, open the frame, and pull the packet out. So your computer knows how to encapsulate a packet into a frame and also how to decapsulate a frame and pull a packet out. In other words, it knows how it is able to receive packets. It knows how to send packets and it knows how to receive packets when you are testing a 127.0.0.1 address. Okay, so please write that down. The 127.0.0.1 address is the loopback address, and it's used to test the local host for connectivity. All right, static IP addresses is when you type in an IP address on the computer on the host and it does not change. A dynamic IP address is where the IP address is given to you by the DHCP server, and if you close your computer, you're going to lose it. You unleashed an IP address and it will change. So please write these 2 down. I want to make sure you know the difference. So when I say in class, we need to assign a static IP address to the PC and you type it in, the computer will always use the static IP. it takes precedence. So it's gonna if you type in a static IP on your computer, it will always use that. And if it's not given to you by the DHCP server, most likely you're not going to get on the internet with it. And a PIPA address, an automatic private IP address, is an address that starts with 169.254. All right. So if you type in ipconfig and you see an address that starts with 169.254, and it doesn't matter what the last 2 bytes are, then you know that your DHCP server is down. Please write this down as well. That's important. That's a good troubleshooting hint. So if you type ipconfig and you see that the computer has this address, starts with 169.254, you know your computer did not communicate with the DHCP server, did not get an IP address. It could be that the DHCP server is down, or it could be that you're not connected. So therefore, that's why you're not connected to the network. All right. To get on the internet, you have to have a public IP address. Okay, that's you have to purchase from your service provider. But inside your LAN, if you're not going out on the internet, you can use your private IP addresses, and those are free of use. And the private IP addresses, please write these down. Anything that starts with 10, 172.16 to 172.31, 192.168 to 19, and doesn't matter what the last 2 bytes are. So that's why your computers at home most likely starts with 192. At work or on campus, you may, or at school, it may start with 10 and 172. And you can make these up. Nobody's going to bother you as long as, you are within your own private LAN. You can use these IP addresses and nobody's going to bother you. You can set up your voice over IP in your LAN. You can do whatever you want. But if you need to get on the internet, this private IP address is sent to your router, and then your router will convert the private IP address to a public one, and then you get on the internet with that. And when you come back, you're translated back to your private IP address. Who does the translation between public and private to public? It's called the NAT, N-A-T, the Network Address Translation Protocol. So write this down. NAT runs on the router, and it translate private IP address to public and public to private. The advantages of NAT is it conserves, I'll keep writing, conserves public IP addresses, and it's more secured. The disadvantages, write this down as well, is the delay that it creates, because you have to wait to be translated in and out. So it is not appropriate for voice over IP, streaming videos and things like that, where these applications, latency sensitive applications such as voice over IP or any real-time communications. All right, so that's NAT. We talked about that. That's where you get translated to go publicly on the internet. You need to be translated from your private to public and vice versa, right? If you attach a port, that's called port address translation. That's PATS, which is really a form of NAT, but PAT allows multiple IP addresses using the same IP address with different ports. So one IP address, just attach different ports to it, and I can accommodate several internal private IP addresses. That's what PAT does. That's what your home router uses. Okay, we need to know about. Let's talk about IPv6. IPv6 consists of 128-bit number. So please write all of this down, these notes, right? And each number is a 4-bit number. This is a hexadecimal number. Remember, a 2 in binary, a 2 in hex is 0011. And this is 4 zeros, this is 4 zeros, this is 0001. So this whole thing before the colon is 16 bits. It's called a hextet. So you got 8 hextets. 8 times 16 is 128 bits. Okay? When you have a lot of zeros, you can eliminate these zeros and just put an empty colon in between, right? It makes it easier. So for example, with this address, you have a whole bunch of zeros. You can just eliminate the insignificant zeros. Just write 1 0 here. Eliminate the insignificant zero. Eliminate the insignificant zero. Eliminate 3 zeros, 3 zeros. When you see consecutive zeros, so instead of writing all of these down, you can write them as empty colon. But you have to write this zero down here. It should have been written, by the way, 1 0. You don't have to write 3 zeros. So you can make it actually more concise. How do you know? You cannot do empty colon here, by the way, right? You can only have one empty colon in an IPv6 address. Why? Because you'll be able to get back the original IPv6 address from here. Because I know I have one hexstat, 1, 2, 3, 4, 5, 6 hexstat. I'm supposed to have 8. I know the empty colon is 2 zeros and I can fill it up. If you had this as also empty colon, and I have 5 hexstats left, I'll have 1, 2, 3, 4, 5. There's 3 hexstats left. How do I know if it's the 2 is here and 1 is here, or 3 here, nothing here? You'll get confused, so you won't be able to do it. That's why you only need 1 empty hexstat. Okay, so when you see an empty hexstat, that means there's zeros in here. How many zeros? Just find out how many hexstats are there, and the leftovers are where the empty colons are. Okay, so that's a typical. Please write all of this down for your IPv6 address. Okay, a link local address is an address that is used inside your LAN, only your LAN. You won't be able to use it anywhere else. You cannot communicate with it. So every IPv6 device will have a link local address that it uses to communicate with devices inside the LAN. All right. Tunneling is a method that is used by IPv6 to transport IPv6 packet to IPv4. And the interface ID is the host portion of IPv6 address. Neighbors are whoever is in your LAN, in your link. Excuse me. Unicast addresses are also, please write this down. A unicast address is an address that is sent to a single host. So when you want to send data to a specific host, that's called unicast. If you're sending a packet to multiple hosts in a LAN, not everybody. If you're sending it to everybody, that's a broadcast. If you're sending it to multiple hosts in a LAN, that's called multicast. Any cast address can identify multiple destinations with packet delivered to the closest destination. So for example, you can have an address given to several devices in your LAN, and when you send a packet, the guy with the closest to you will get it. Let's say you given an address of 1.1.1.1.1.1 blah 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 as an IPv6 address to several users in your LAN. So you want to send a packet to address 1.1.1.1.1.1.1. The first guy who's going to get it is the one who's closest to you. Any cast address means anybody that grabs this address first gets it, right? That's what it really means. Here's one thing to remember. We really don't do broadcasting in IPv6. We only do multicasting. So there is a special multicast address that performs the broadcasting. So I'll just send it, instead of sending it to a group of people, the group is everybody. It just really simulates or mimics what a broadcast address is. All right, couple of things. I want you also, we'll go into this details as well in class. A global address, which is please write this down here. This is important. I need you to make sure you write all of these down, this chart right down here. A global address is this is an IPv6 address that is used to get on the internet. So if your address starts with 001, which means it starts with the number 2 or 3 by the zero. It starts with number 2, then you have a global address, address that you get on the internet. If you need to get on the internet, you must have an address that starts with 2, right? The first nibble, the first 4 bits. If your address starts with FFE8, typically it's right FFE880, and whatever you write after that, that's a linked local address. If your address, so you're going to get 2 addresses typically, a linked local address, an address that starts with FE80 something, and an address that starts with 2. The address that starts with FE80 is the address that you communicate with your devices inside your link, inside your LAN. You cannot use this address to communicate with anyone outside your LAN. All right. If you need to communicate with anybody outside your LAN, you're going to use either your global address to get on the internet. This is an address that you can use on the internet, or you can use a unique local address, which is this is like a private address to talk privately to another LAN, but not on the internet. This is the difference between the unique local and the global unicast. The unique local is the one that enables you to communicate with other LANs privately. This is similar to the private IPv4 address. So if your address starts with FC or FD, you're in a unique local. Most people don't bother with that. If you need to communicate outside your LAN, you use a global. Inside your LAN, you are using a link local. So I'm going to show you, hopefully in class, on how to use these 2 addresses and how to convert them. A multicast address is the one that starts with FF. Okay, the first, 2 nibbles, the first 2 bytes, the first 2 nibbles are 111111, right? Remember, this is F, right? How do you know it's F? It's 8 plus 4 plus 2 plus 1. That's 15, and that's an F, right? In binary. That's why we had to learn that in the beginning, right? And when you type ipconfig, you'll be able to see your IPv6 address and IPv4 address. In fact, let me try that. So here, I'm going to type CMD. And let me see if I can make this a little bit bigger so you can see this. Hold on a second, let me just move this out of the way. Come on. Okay, here we go. I moved it. There we go. All right, let me type ipconfig space /all all. So here's a typical, this is your MAC address. It's Qualcomm. Remember the first 24 bits. This is 8, 8, and 8. 8 times 3 is 24 bits. This is written in hex. This is your physical address. This is the OUI. And this is the 2FB8CE. If you Google this number and say, what is the vendor address for this IP, it's going to tell you it's a Qualcomm. It came from Qualcomm. I have a link local address. See, a link local address starts with FE80. That's my link local address. That's the preferred. I can use that, or I can use my IPv4 address. 192.168. See, it's private IP address. This is given by my computer. This is the mask address. This is to mask this. My network is 192.168.10 because the first 3 numbers are 255. It's telling me that the first 3 numbers is my network address, and I'm this host. So typically I either can use this or this to communicate inside my LAN, right? Here's my default gateway. This is my router at home. This is where I go to. See, the first 3 addresses are the same as this. My router is .1, right? Because this is a class C. My router is .1, and I am number 107. Okay. My DHCP server is the same as my router. I do not have an IPv6 address to show you, unfortunately. But here is, here's a typical IPv6 address. Don't worry about this percentage 12. Okay, so you can actually rewrite this, right? See this empty How many zeros are in here? So you have one hexstat, two, three, four, five. That means there's three zeros here, right? This is my network ID because the first four is your network address and the last four hexstats is your up to here is your host portion, network ID. All right, so let's go back and continue. So how do auto configuration? By the way, you don't need an IPv6. You don't need a DHCP server really when you're setting an IPv6. If you configure your router with an IPv6 address, your computer will automatically go to the router, grab the first four hexstats from the router, and it will create its own network address, append that to the four hexstat that was given from the router, and you got your IP address, your network IP address. So that's how it would work automatically, and I'll show you how that's done in class. If you have a network 4 and an IPv4 and an IPv6 address, you can use dual stacking. Dual stacking means you run both at the same time. If I get an IPv4 address, I'll let the IPv4 software to process that. If I get an IPv6 address, I'll process that as well. All right, so please write that down. A dual stacking is a term given when the network is configured to use both IPv4 and IPv6. And the three, or you can, by the way, do tunneling. So write that down as well. You can actually converting IPv4 to IPv6 and vice versa. 6 to 4, hardly ever used. The ISOTAP is for inside your LAN. The Tiradora is to convert IPv4 to IPv6 to go outside on the internet. Okay. When you type ping, so please write this down. Where for ping is called the packet internet groper. So what you're going to do, this is to check the connectivity of another device in another LAN. So when you type ping, you are sending an IP address after that, ping space an IP address. You're saying, is this device connected? If it responds back to you, that means it's connected. If it does not respond back to you, that means that device is out, or the connection between you and that destination is not there, right? And by the way, this is called an echo request when you ping an IP address. You're requesting you're requesting a reply. If you get an echo reply, that means he's there. If it dies out, that means the connection or the device itself is down. The ping is part of the ICMP protocol, the Internet Control Messaging Protocol. That's what the ping, the echo request and the echo reply. Okay, so there's a whole bunch of different pings, and you should definitely be familiar with these. The -A. What else? You can put either ping with /? or $? for online help. T is keep pinging until you are interrupted. This is, you do control break. Otherwise, it just keep pinging this address. Unlimited ping. This is, you can create a sort of an attack with that. And N, and here you're saying, defines the number of echo requests. I need 2 of them. So I want you to write down the -T, the -N, and the -A, and what they mean, right? Those 4, in addition to everything else, of course. We'll hopefully you'll practice some of those as we move along. You could do the same thing with ping. All you have to do is ping 6, and then you can type in the address that you want. ipconfig, just like I wrote, this is for, you can use all the different types of IP configs. So please write this down. This is important for ipconfig for the command prompt. This is going to tell us all because you'll be needing this. Please type those down. I know it's a little bit of work, but this is important. ifconfig is really for Unix. It's similar to ipconfig. You don't have to write this down. If you want to, that's fine. NSLOOKUP. NSLOOKUP is important because write this the first, at least the first note. It allows you to create the DNS database from any computer on the network. You can find out the host name of the device by specifying its IP address and vice versa. So you'll get to play with this a little bit. Use, for example, you type in NSLOOKUP on here. Okay, let me just see it. So when you type in, it's going to tell you the server. So if you type in NSLOOKUP www.cengage.com, it's going to tell you the server and the IP address of it. Right? It's very nice. If you type in just NSLOOKUP, it's going to tell you your default server and your IP address. Play around with that a little bit. It's good. You'll know who your DNS server is and what the IP address for this is. So if you want to know the IP address of yahoo.com, let's type nslookup www.yahoo.com. So let's try that. I haven't done that for a while, so let's see how that works. So I'm going to type in nslookup www.yahoo.com. And there you go. Server is unknown. Authoritative is the name is, here's the server, and here's a whole bunch of different network addresses. Aliases is the yahoo.com server. Okay. All right. Let's continue. And let's look up, and that's it. All right. So I don't think I thought it was going to be lasting long, but this is long enough. Anyway, so please write everything down I told you. Don't forget the stuff that I wrote down here and include everything that I asked you to write down here. And we'll get some class activity. You'll have a better details, better understanding on IPv4 and IPv6 address. I'll show you how the DNS and the HTTP server work together. And so make sure you write this down, submit it as homework, and I'll talk to you. Well, it took about an hour. That's not bad. Don't forget, please take 20 minutes or so, then take a break so you'll have a good understanding and you're not really distracted at all. All right, I'll see you on the next chapter.